Hi guys, how are you doing? It's science time and today we will be discussing about the concept of pressure and volume and their differences and their own properties. But guys, today our video is going to be completely different and it's not going to be no more PowerPoints, and today we will be checking out some experimental resources, online experimental resources, so we can comprehend the topic in a much greater way. And guys, before going to this video, I will be asking you to subscribe my channel. Don't forget to like and drop a comment, put down your reaction, and feel free to ask any educational questions that came to your mind. So let's do this. So guys, as you can see, this is a container and all things can be measured. But in this case, in this experiment, we will be talking only about pressure, temperature, and volume. So no need about other options, but also indeed it has other facilities as well. So guys, at first, I will be adding 50 heavy particles. So guys, as you can see, I'm saying heavy, which means that their mass is really high. Therefore, they are having less movement compared to light particles. And light particles, as you can see, they can move much faster compared to heavy particles. And why? Because their mass is less. Therefore, they are going to collide with each other in a much higher rate. But at first, no difference. But at first, I'm going to put on I'm going to bring 50 particles of heavy particles indeed. So guys, as you can see, the temperature is 300 Celsius and the pressure is like, how can I say, like nearly 5.5 to 6.2 or 6.3, no difference. And guys, like in this lesson, I will be proving you, my viewers, my subscribers, that P1 V1 equivalent to P2 V2. I mean that these two are inversely proportional. So as the temperature is constant, whenever the volume is going to be decreased, the pressure increases, and while the pressure decreases, the volume increases. And that's only when the temperature remains constant and the number of particles, or let's say the total mass of particles being used for that experiment, remains constant. And if it's not going to remain constant, everything varies. So guys, I'm going to decrease the volume. Let's see what happens to the pressure. So as you can see, pressure increases. So this means that they are inversely proportional unless the temperature is going to be changed. And guys, let's notice all the times that volume and temperature, they are proportional. But the thing is that there are some devices that we can encourage and force the volume to remain constant for a certain period of time. But we don't have any device for forcing the pressure to remain constant. Therefore, we cannot do anything with it. Therefore, we can only force the volume to remain constant. So guys, let's increase the temperature. Let us see that is the container is going to be completely destructed or no. So guys, as you can see, I'm heating. So as you can see, guys, the average kinetic energy of the particles is getting high, as you can see. Like, let me stop. Like, as you can see, guys, compared to the last minute, these particles are moving really fast, which defines that their temperature is higher. And since their temperature is higher, their average kinetic energy is much higher and more energy is being composed inside themselves. So they are going to apply more pressure on the wall of the container. Therefore, the pressure increases. So let me continue heating it. So guys, as you can see, the temperature increases time to time. Let us see. So the kinetic energy increases. And guys, look at this. So the temperature increased that much, which the volume wouldn't be able to stay constant anymore. So that means that wall of the container is going to be completely exposed. It's going to be completely destructed whenever the temperature is going to get higher from an optimum level, from its optimum level. Therefore, it's not like this, that as much as we are going to increase the temperature, the volume can remain the same. It's not like this, because I'm saying that this is the fact, this is the exact statement, that the volume is completely proportional with the temperature. So we can only force the volume to remain constant until a certain point. So, and guys, we are done with this online experimental resource. So now we are going to go through like a couple of questions so we can understand the topic more efficiently. So guys, let us know about, like, as a summary, what we learned from that experimental resource. So guys, until now we know about the formula P1 V1 P equivalent to P2 V2, and these two are going to be exactly the same, since as the temperature remains constant and the number of particles, or let's say the total mass of the particles being used, is not going to be changed, it is not going to be flexible. Therefore, these two are going to be completely equal with each other. As the pressure decreases, that means if the pressure is being divided by 2, and the V1 is going to be multiplied by 2 for being converted into V2. So they are going to be decreased and increased. They are going to be changed at the same rate. Don't forget this. And also we notice in general that while the temperature remains constant, pressure and volume, they are inversely proportional. But even though volume and pressure, they are proportional, but since some devices are like they are present, they are available for us for forcing and encouraging the volume to remain constant until a certain point. But after the temperature achieved and rised from that optimum level, from that optimum temperature, the wall of the container, that container is going to be completely destructed and opened indeed. And also, in general, we know that pressure means the collision of the particles with themselves and the force and the pressure which they are applying in the wall of the container. And therefore, whenever we were heating the particles like in a certain volume, we saw that the pressure is increasing, which defines that pressure and temperature, they are completely proportional. So this means that as the temperature increases, as I said before in our last video, so don't forget to take a look and check out my last video, which is really helpful, related to the kinetic model of matter. So as the temperature increases, the kinetic model of matter related to this concept, the average kinetic energy of the particles present in the container is going to increase. Therefore, they are going to move faster, and as they are moving faster, they will be able to collide with themselves and the wall of the container in a much faster and greater rate. Therefore, they will be applying more force and more pressure against the wall of the container. Therefore, the pressure increases. So let's go through a couple of important and crucial questions. So question number 1. What's the formula for Boyle's law? So guys, pause this video and answer it. So guys, as you see, what's the formula of Boyle's law? Choice number 1, P1 V1 equivalent to P2 V2. Choice number 2, P1 divided by V1 equivalent to P2 divided by V2. Choice number 3, P1 V2 equivalent to P2 P1. And choice number 4, P1 V1 divided by P2 V2. So guys, indeed the answer will be choice number 1. And why? Since they are inversely proportional at a constant temperature, which simply defines that the P1 increases for becoming P2, while in that case V1 will decrease at the same rate, as I said before, for becoming V2. So the answer is 1. P1 V1 equivalent to P2 V2. So guys, there is a tip here related to question number 1. that in a constant temperature, pressure and volume are inversely proportional, and its diagram, its graphical line is completely shown. As you can see in the vertical line, as volume decreases, the pressure increases in the horizontal line. So let's go. So the second question. A gas of volume of 4 decimeter cube is at a pressure of 8 pascals. The volume is changed to 16,000 centimeter cube. What must the new pressure, or let's say P2 be? So guys, in this case, we have to refer on the formula. So let's do this. Pause the video and think about it. So, the answer to question number 2. Here is the base form of the question. Choice number 1, 1 pascal. Choice number 2, 12 pascals. And choice number 3, 10 pascals. And choice number 4, the last choice, 2 pascals. So indeed, as I said before, after I read the base form of the question, that we have to refer on the formula. P1 V1 equivalent to P2 V2. So guys, as you know, and you must know it for RGCSE, that 1 decimeter cube equivalent to 1000 centimeter cubes. So in that case, we know that all units, as I said before many times in my last videos, that the units have to be in SI units and they have to be same as each other. That means they have to be related. Therefore, indeed, I will be converting 16,000 centimeter cube into decimeter cube. So in that case, it would be 16 decimeter cube, which means that it is being multiplied by 4. What do I mean? That 4 decimeter cube is the volume, or let's say it's a V1. And V2 is 16 decimeter cube, or in other words, 16,000 centimeter cube. No difference, but the units have to be the same for each concept. So 4 multiplied by what number is equivalent to 16? So indeed 4 multiplied by 4 squared equivalent to 16. So it is being multiplied by 4, V1 for becoming V2 in the other side of the equation, as you can see. Therefore, I will do the same thing but exactly the opposite with the pressure. So P1 for becoming P2, it has to be divided. It was multiplied and now it is going to be divided. Since, as I said, while the temperature is being constant, the volume and the pressure are inversely proportional. So 8 divided by 4, P1 divided by 4 equivalent to P2, which is equivalent to 2 pascals. So choice number 4. So let's do this. Question number 3. Which container will have a lower pressure? So guys, as you can see in the picture, the left one is having this. And guys, don't forget this, that these two containers, they have the same amount of particles, and the total mass of the particles which is involved in this experiment is the same for both containers. So think that the temperature is constant, and also the total mass of the particles in both sides are also the same. So let's do this. Pause the video and think about it. So answer to question number 3. Which container will have a lower pressure? Choice number 1, right. Choice number 2, left. Choice number 3, they both have the same pressure. I'm sorry, it's right. It's written there. It's they. Choice number 4, no idea. Oh my god, what is this? Yeah, guys, indeed, it's choice number 4. So guys, the answer, it says it is going to be left. So choice number 2. Since the more volume, the less pressure within the particles, unless the temperature, or in other words, the number of particles, or let's say the total mass of the particles, and a lot of factors, they can be changed for this statement to be completely wrong. So guys, in these types of questions in IGCSE, if the temperature or the number of particles being used, if it is going to be flexible, like in any sides, no difference which side, indeed it is going to be written. So when it's not written, means that the temperature remains constant, and the number of particles and also the total mass of the particles in both sides are going to be constant. So the answer is choice number 2. And now a tip to question number 3. So guys, we noticed, as I said before, when we were talking about that online experimental resource, we said that the pressure will be produced and created when the particles are going to collide with themselves and the wall of the container. Therefore, they are going to apply a kind of force into the wall of the container. So the atmospheric pressure doesn't going to play any role in this concept. So guys, I hope you enjoyed this video. Don't forget to subscribe, like, and comment. Put on your reaction, drop your reaction, and feel free to ask any educational questions that came to your mind. So guys, have a great day and see you in our next video.